We're going to add 1 pound of ice to our container. The specific heat of water was 1, specific heat of ice is 0.5. That means if I add a half a BTU to 1 pound of ice, the temperature will increase 1 degree. When we are adding heat which causes a change in temperature, that is called sensible heat. Our ice is starting to melt a little bit. It took 144 BTU to melt our 1 pound of ice. We call that latent heat of fusion or latent heat of melting. To boil 1 pound of water is 970 BTU. So not only are we adding BTU, which is being used to raise the temperature of the water, we're also simultaneously adding latent heat, which is being used to boil some of the water. By boiling a fluid such as this, we are removing heat from everything else in the area. We probably all had the experience of walking away from a pot while we were cooking on the stove and we came back and it was burning up. That's because the specific heat of metal is far lower than the specific heat of water. That little bit of water evaporating is keeping this vessel cool. If it were not for that little bit of water, this thing would be like 300, 400, 500 degrees. That's how powerful latent heat is. Latent heat is so many BTU being absorbed at one time that it is keeping this vessel from burning up right now. This is what is taking place inside of our refrigeration systems. So I can hear the little popping of the little final drops of water there. See the little pops, the little final drops of water. 261, that quickly. We just went from 212 to 261 degrees. 372, look at what's happening to the metal. So the metal is shooting up in temperature because we have no more 512 degrees. Okay, we started with 1 pound of ice, which we melted into water, and then we evaporated that 1 pound of water and turned it into 1 pound of steam. So 144 plus 180 plus 970. So we just witnessed at least 1,294 BTU being absorbed. How cool is that?